Okay, we're back with the CPI CP2000 base. The power supply has been reinstalled, so all of the electrolytic capacitors were replaced like you saw earlier in the video. Everything's put back in and got it in here, rewired, everything hooked up, turned the power on, and no display. The lights came on, we had some sound, but no display, no channel selector, basically a little bit of, I'll turn the volume, speaking of which, volume, turn that down, it's hooked up to an antenna right now. So go in and go to check for some voltages, and what the hell pin is it? This white wire here is supposed to have 5 volts on it, and that's to, remember, if you remember right, there's 2 large TO3 package transistors on the bottom side, one right here and one right there. Well, the one that's right there is actually just a 5 volt voltage regulator. It's in, they have MC, 7805, CKs, I think, in this. Oh, here. Yeah, MC 7805 CKs. It's just a 5 volt voltage regulator. It wasn't working. So, yeah, you know, just but I got that replaced, which is actually fairly easy. It's, you'd think, oh god, you got to tear this power supply board back out. No, it's just a matter of just desolder those two pins right there. Take the nut and the screw off of the underside, and voila, the old one fell out. So there's the old one, which is dead. And I tried it, on the bench, out of the radio, and yeah, it's dead. So, very simple to hook up. Let's see here. In this orientation, the body of it goes to ground. They're nice enough to mark these. You see there's a B right there, the base, that would be your input voltage. So if you apply voltage between the outside shell and this pin, you should have 5 volts here. Well, I didn't have anything. It was and is dead. So it has a new one installed, and it's working fine. So actually I can turn the generator down some here. Flip over to dummy load. Turn the squelch down. Volume up. Haha! We have sound! It's alive! The customer is going to be tickled pink. So, haven't even tried transmit yet. I honestly could care less at this moment. It's working, and it has a good EEPROM. That's the main thing. The EEPROM is alive. It's not dead. Power supply board's now working fine. Everything was, well, actually, I didn't re-grease the 2 small transistors. The bridge rectifier right here was re-greased with thermal grease, but the 2 small ones there, right here and here, I actually just installed more modern thermal pads, the silicon thermal pads like you find on everything nowadays, because those you don't have to worry about drying out over time. So, but yep, it's alive. So it looks like we will have, within the next few hours, I still have to, probably more than a few, because I have to recap all of the other boards. And of course, as you can see, this board is not exactly easy to get to components. So I've got some major dismantling to do, but yeah, so basically it's just a matter of recap it. I will pop a cord in it eventually to make sure it does transmit, but yeah, that's, well, hell. Let me just grab my dummy cord here. And we'll actually see if it does transmit. My cord unraveled here. Okay. Okay, let's see. These should be, push to talk should be 3 and 4. So this one and this one. Haha! It's alive! I'm trying to do this with one hand. Power's a little low. Showing like, oh, what the hell scale are we on there? 50 watts, so yeah, it's showing like 1 watt, but honestly I could care less. 1 watt, 500 watts. It's got power. So actually, let's even go so far as to check the output frequency and see if we actually have output frequency anywhere close to the channel that we're on. Okay, so I've got 3 and 4 tied together there. And we'll plug the mic jack back in. And 27.184.826. So extremely close. That's, that's just a matter of bringing it into alignment with the, when I do the alignment. Oh, actually, the clarifier is unlocked. Just turn the clarifier here. As you can see, as I turn the clarifier. So, okay. Anyhow, right about there is centered. So yeah, it's only off about 140 hertz, so extremely close. It's actually not bad. Like I say, output power is a little bit low. No problem. And that might just be, like I say, none of the other capacitors in this have been changed yet. The only caps that have been changed are on the power supply board. And that also includes the 2 tantalum capacitors, one right there and one right down in there in front of the audio IC. Yeah, because these things have some age, and this had the old, multicolored ones. They don't even print, the values on them. They use the old color code scheme. These are 2.2 microfarads. But anyhow, both of those have been replaced. So, 2 little time bombs were changed. I think that's about actually all the tantalums that are in this thing. There might be one down on the front board here. I don't think either of the interface board or any of the other ones have any tantalum. So yeah, that's probably about the extent of it. So, yep, time to recap it. And we'll go from there. And if nothing else, even if, hell, I were to have low output power and it's the PA unit in this thing, I don't even need to fix it. I've got the PA unit that I know for a fact works fine out of the other unit, because, hell, I got like 15 watts out of that thing. It was, several bands off, several megahertz off frequency, because it was just at random because the EEPROM was bad in that one. But, yeah, hell, worst case scenario, what I can do is just pull the 2 RCA jacks out, unplug it, pop the screws out. Actually, this one has a tamper-proof head screw, where the other radio actually has, because from the factory they'd either install, in the beginning they installed rivets, and then later on they used tamper-proof head screws. They're just Robertson head. But, yeah, so I mean, hell, if there is a problem with the PA unit, it's easy enough for me to just swap the PA units. 6 or 8 screws, a plug, and 2 RCAs, and I can just pop another PA unit on there. But main thing is it's alive, it receives, and it transmits, and it's on frequency. So I could care less if the power is high, low, it doesn't matter where it's at. That can be easily fixed. The main thing is it is alive. So there you go, the CP2000 base station from CPI, or Communications Power Incorporated. Okay, the deconstruction continues on the CPI CP2000 base. As you can see, it's a tad bit on the hollow side now. Now, they did make these kind of halfway easy to work on, halfway not. Power supply, not too bad. Like I say, the entire module drops out the bottom with a minimum amount of wiring that has to be removed. But you do then have to desolder the transistor and the 5-volt voltage regulator to remove all the nuts to get the board up and out. But that's not that bad, as far as servicing. These 2 boards are extremely easy to get out. This one requires no desoldering whatsoever. Just a couple plugs, and then there are header sockets in the front board here. You can see the rows of pins on each side for both of those boards. So, like I say, it's basically just a matter of removing the screws from the underside, to 6 screws on each. Same for this board, to pop it out, and then same with this board. The only difference here is you do have to desolder 2 wires. There are 2 wires, this one and this one, that go down to that board, but everything else RCA jacks. So, and there's a lot of other ones there over there on the board still. But Yeah, and then it's actually the same for the PA unit. Another very easy to access and work on module because it's a modular design. Eight screws, 4 along top, 4 along the bottom. Actually, I think there's another 2 on this side, on this side here. So actually, there's 10 screws around the outside edge of the RF amplifier unit. RC cables are already pulled. So I can pull them out the back. Just basically disconnect the plug. PA unit falls off the back. Now the PIA, I guess we could say, on this is the front board. That board right there. Now this board's not too bad. It's kind of stuck in there because this is not a socket. These are just headers that are soldered on both sides. So that's not actually, pins and sockets. But there's enough room. The only thing you need to get to in here are these 2 electrolytic capacitors. So that's easy enough to do with the board in. This front board, however, that's another story. Because as you can see, there's really no way to get that out without some major dismantling. And the big problem there is, you see all those old ass electrolytic capacitors back in there. They're shoved down in there. There's some tantalums. I doubt you can even see them. They're back in there so far. Grab a flashlight here. With some more of those little... You can see the little... They're kind of hard to see, but right there, right above my fingernail, if you look, see the brown top, black and green. Because they look like the old tropical fish capacitors, the color codes. But there's a couple tantalums in there. Now the easiest thing to do with these is when you replace these, do it just as it sits right here. Honestly, because the only way to get some of these electrolytic capacitors was not so much getting them out, because the leads are short, you can get them up and out. The problem is trying to fish a new capacitor in there. Notice all of these switches are soldered directly to this circuit board. And where is that capacitor sitting? Dead in the middle, buried. Especially that one, that one back in there. It's buried underneath of this switch right here. So there's really no way to get in there to try and fish the leads in through the hole. So the easiest thing to do is, there's lots of room right here. The board sits way down here on this chassis. So what you can do is desolder. You can be able to get in here with your desoldering iron, very easily. Get in here, and desolder all these components. So, that's not a problem. So we can then just come in here, pop these out, and then when we install the new capacitors, we can just put them on the back side of the board, because these are through-plated holes, because remember, this is a double-sided circuit board. Okay, so every hole is through-plated. So that makes it very simple to just move the capacitors on the back here. Real estate's no problem, because all of this is in wide open, right here and right here. There's absolutely nothing here. So, and the one thing that really, really, really sucks about these radios, and I hate it for them doing it, things like if you ever have to change that switch and several other things on here, you're screwed. There's no way to get to it without damaging this radio. And I say damaging the radio, I mean the face decal, this plastic decal. You see that? Screw thread sticking out the back side, okay? Where in the hell is the screw head? It's behind this damn plastic decal that is glued to the front steel chassis of the radio. And I've seen other stuff like this. I've even seen test equipment like this. And every time I see that, you just cringe. You just think, God, they made some of this stuff so modular, so easy to get out. And then they go and do something stupid like that. So, yeah, there are some things in these radios that you just better pray never go bad, because you're never going to be able to get to it without, damaging this face, this thick, decal. I really don't see a way of getting that off very easily. You could probably try heating it, but yeah, you're just going to end up probably kinking it, and it'll be noticeable. So, but in any case, like I said, easiest thing to do here is desolder the components, remove them, and just reinstall them on the back side of the board. Now, the 2 boards that were removed, of course, that makes them extremely easy to service. Get them over here on the bench now. So this one would be right here. And this one right here. This is the way they were in the radio. So, now all I got to do, clamp these in a PCB vise, and I can just have these floating in midair in a PCB vise. Extremely easy to work on. So, and being out like this, it gives you a opportunity to really inspect the radio to see if there's, anything else needs attention while it's out. Give it a good cleaning. Like I say, change the electrolytic caps, and, do its, 30 plus year maintenance before it gets put back in service. But, yeah, we want to be gentle with this board, because this board right here it's not so much this board, it's this chip right here. We want to pet him, because we don't want him to ever go bad. That's a good chip. Now, I think one thing I'm going to do with this, and I've done this on, actually one of my radios, one of these, I have one of these, I did it too, and I've done it to a few other, not just radios, some electronic devices. Some chips, just some ICs, run, oh my god, nuclear hot. So, on this board, this one, and this one are basically miniature nuclear reactors, and this EEPROM gets rather warm. It's not as hot as these. These three get ridiculously hot, and this gets rather warm, and we definitely don't want this thing to get hot. We don't ever want this thing to deteriorate and break down. So what I do is I apply heat sinks to them. Now, the easiest way to do that, I've got mountains and mountains and mountains of aluminum heat sinks that I've scavenged out of, electronic junk. Everybody gives me all their electronic. People are like, why do you want that old electronic junk? Because I get all kinds of good parts out of it. One thing being heat sinks. So, I'll take a heat sink like this, take it out on a bandsaw, and it works out, if you look at it, 3 fins is the perfect width to fit right on top of that IC. And 4 fins perfectly fits on top of that one. So what I'll do is I'll take it out on a bandsaw, cut that ear off, count over 4, make a flush cut, count over another 3, so there's 3 fins, and I'll make little heat sinks. And then use thermal conductive glue, which is just for that. It's not electrically conductive, but it's thermally conductive. Even some CB radios and ham radios, occasionally you'll see that. I've seen it used like for bias diodes, where they'll actually just glue the bias diode directly to a driver or a final transistor. And that's what I use. Just put a little bit, very thin coating of thermal conductive glue onto the tops of these, and then just put my little cutouts, and it'll be perfectly, fit on there just perfectly. They'll cover all the surfaces, but then that gives them a little bit of heat sink to help dissipate any heat that they're generating. Especially these 3. Like I say, these things are like little furnaces. But yeah, this one we definitely want to protect, because there is no replacement for this IC. So if this EEPROM goes bad, this radio turns into another brick. So there's the progress in the dismantling of the radio. So now let me get busy and recapping. Oh, and if you're wondering, this empty socket here, that's not actually an IC socket. That's the another header socket that comes down off the channel selector that would be sitting right about here in the radio. That's that double ribbon cable comes down, and then both of those ribbon cables go into a little housing that has these 2 halves of the pins, a little socket, and then plugs in there. So there's not an IC missing. That's actually where the ribbon cables hook up for the channel selector and a channel display. So there's what the insides of the CPI 2000 base station look like, and we'll return after we get them recapped.